Welcome to the VOLTRA tutorials. You can download the corresponding exercise files from the link provided in the description of the video. In this first tutorial, you will become familiar with the VOLTRA interface. VOLTRA is the extended dynamic version of TRISCO, and therefore the interface is very similar. For a detailed explanation of the modeling approach, it is recommended that you first review the TRISCO tutorials. In this video, we will briefly introduce the tools necessary to build and calculate a simulation model in VOLTRA. To start a new project, go to the File menu and click New, or use the New icon in the top toolbar. You can also open existing VOLTRA, TRISCO, or TRISCO 2D files by selecting Open from the File menu or clicking the Open icon in the toolbar, then choosing the desired file. Alternatively, you can also import a BISCO or BISTRA file in VOLTRA by selecting Import Data from the File menu. Please note that when you open or import from TRISCO, TRISCO 2D, or BISCO files, which are steady-state programs, the dynamic material properties are set by default to 1000 and need to be adjusted by the user. When a project is opened, you will see four main windows: the Image window, the Grid window, the Blocks window, and the Colors window. The overall interface closely resembles TRISCO. However, because VOLTRA performs dynamic simulations and includes a solar processor, the Colors window contains additional parameters such as density, specific heat, sun, solar reflection, and solar transmission. These additional parameters will be explained in detail in later tutorials. By default, the model starts with a 1 meter cube grid, with one unit in the X, Y, and Z directions. The grid is automatically linked to the Blocks window. You can zoom in and out using the scroll wheel. To orbit the model in the Image window, hold the left mouse button and drag. If you right-click on a block in the Image window, the assigned color is highlighted in the Colors window and the corresponding block is highlighted in the Blocks window. We will create a 1 meter square wall section consisting of 20 centimeters of concrete, 20 centimeters of insulation, and another 20 centimeters of concrete. First, we convert the grid unit from meters to centimeters. Go to Grid, then Grid Unit, and enter 0.01 meter. Confirm the transformation of grid widths. Although the grid unit has changed, the overall model still represents a 1 meter cube. Next, we add two new grid cells in the X direction. Select the X cell and use Insert After twice. Change the dimension of each new cell to 20 centimeters. Then go to the Blocks window and use Insert After to create corresponding blocks. Assign block number 2 from position 1 to 2 in the X direction, and block number 3 from position 2 to 3. Change the color of the first and third blocks to color 136 and assign color 151 to the middle block. For this exercise, we are using colors from the default Physibel color database. These colors can later be customized to modify material properties or boundary conditions. We now insert two additional grid cells for boundary conditions. Insert one cell before the first grid cell in the X direction with Insert Before and one cell after the last grid cell with Insert After. The thickness of boundary condition cells does not influence the calculation, what matters is the surface where they are applied to. For visual clarity, we assign them a thickness of 10 centimeters. In the Blocks window, assign color 170 to one boundary cell and color 174 to the other. Boundary conditions are not visible when Show Materials is active, so switch to Show BCs to visualize them. For this example, we define an outdoor temperature of 0 degrees Celsius and an indoor temperature of 20 degrees Celsius. Boundary conditions are defined under the type BC Simple, while wall layers are defined under the type Material. These definitions will be explained in detail in the VOLTRA Colors tutorial. To generate the computational grid, go to Grid and select Auto Split. The default settings are fine for this example. Dividing the grid into smaller cells improves accuracy. You can visualize the computational grid by clicking the grid icon. For additional information about grid refinement, please refer to the TRISCO tutorials. To set the calculation parameters, you can click on the icon at the top toolbar or choose it from the Edit menu. Here we define the time step between each calculation. Say we calculate for every 5 minutes. In this tutorial we have not defined any dynamic parameters yet, so we restrict only a few calculations as it would perform repetitive calculations with static parameters. Hence we input the calculation duration as 15 minutes with 20 minutes startup duration. You can now close this window. From the Calculate menu, select Save Frequency. By default, this option is activated, and we will keep it enabled. This setting generates solution files for each time step, allowing results to be visualized later in the graphic output module. Now select Calculate System from the Calculate menu. You will first observe time steps corresponding to the 20-minute startup period. After that, the software performs calculations for the 15-minute analysis period. Once the calculation is complete, the display automatically switches to show temperatures. Click on Graphic Output to access post-processing tools. Most of these features are similar to those in TRISCO, while tools specific to VOLTRA will be discussed in upcoming tutorials. You may close the graphic output window after reviewing the results. By default, the Colors window displays the List Present option, meaning only the colors used in the current project are shown. If you select List All from the Colors menu, you will see all 256 colors available in the Physibel database. If you choose List Defined, only colors with predefined properties are displayed. Colors used in the current project remain editable. Thank you for watching, and see you in the next tutorial.